All right, we got right. We're right at 8:30, so I appreciate you. I was telling Ted this must be a popular topic because I don't remember the room being this full. And about, you're laughing because you feel the same way. Like it's been a couple of years since we've had the room this full, I guess. So, well, in the good old days, I used to have to call Atlanta. Anytime I needed to get smart on something. It's kind of nice now. Ted's literally our neighbor, basically 100 Calhoun. So when the issue of blockchain came up, I said maybe I can just kind of go around the corner. And thanks to Betsy, who was very generous, basically, to accommodate me, tell me that he'd be happy to make a presentation. Known Ted for years, and I'm just going to read a little bit of his background because he's had a heck of a background. Currently, he's the co-founder and CTO for PocketDoc, which is a company that I can best describe as bringing innovation to healthcare technology, and he'll get into that. But from a background standpoint, Ted's always been in executive engineering with extensive experience ranging from startups to public corporations, including Microsoft and Apple. In the startup world, basically, his startup stints include DigiDesign, which is, and then what's interesting, these are all companies that have been acquired, which is kind of nice. You don't have to go and they fail, and which was acquired by Avid, Crystal River Engineering, which was acquired by Creative Labs, VP of R&D at Mongo Music, which was acquired by Microsoft, co-founder and CTO for Belief Networks, which was acquired by Benefit Focus, and he was also the CTO for Spatialized Audio Labs, which is a publicly traded company specializing in digital signal processing. Ted is also generous, from the standpoint of his time. He serves in the industry advisory board for the University of South Carolina's Computer Science Department, as well as the Center for Intelligent Systems and Machine Learning at the University of Tennessee. He's published extensively in leading technical magazines and holds several patents in the areas of semantics, machine learning, signal processing, and signal protection. So please welcome Ted. This is and I'll probably give away the punchline. We've had these conversations. This is going to go. This is going to go fairly deep. But one of the things that Ted has offered for the technical folks in the audience, that he will come back. We can do a half-day session on an actual learning session, basically, on some of the items he's going to present. So maybe by the end of things we can come up with a consensus of which 4 areas we'd like to hear more about. So let's just kind of keep that in mind. So I appreciate it. Thank you, Ted.
So two additions. Recently, I'm also on the board of directors at the Zucker Graduate Center for Computer Science and Engineering, and also the College of Charleston Graduate Mathematics Board. So I'm a Charleston native, so the tech scene is near and dear to my heart here. But as Ernest said, most of my technical backgrounds from the 33 miles on the other coast. So, we're gonna go through several subjects. And the tagline, if you will, is why I believe smart contracts are the computational asset in distributed ledger and blockchain technology. So here's the overview. I'm going to talk about why we adopted distributed ledger technology. We're going to discuss some very important aspects of DLT. We're going to compare 3 DLT architectures. Like what is a smart contract? We're going to talk about something called game theory, why that is actually occurring now on DLT. I'm going to talk about software agent-based systems, and then I'm going to go fairly deep on something called identity by consensus, and then do an AMA. So first of all, if you're heavily on GDAX and you came here to learn about the latest investments, Bitcoin is not blockchain. Okay, so there's your first chance to get out of here. I think this is a very cogent. Why is this doing this like this? Do we know why? Because I got it on here. Computers are hard. So I hope. That's funny. Some of the code that I built still in there doesn't run. So, did you know? Here's a little caveat. Well, we have an interlude here. Is the
Looks like the projector's off.
the projector's off?
You're fiddling with the.
Yeah. Okay.
Excuse me, all. We'll
Yeah.
let's just. This is what happens when I'm with people.
I've been
This is what
through.
happens when
I've been
people-
through worse. Put it that
The
way.
rating needs to be, yeah.
I've been through worse.
No.
No,
The next
not
slide.
Oh
that.
no,
The settings.
It's the actual setting.
Who's good with fiddling with projectors to get the?
Not me. I'm blind.
Yeah.
Here's a little tidbit. Apple still uses a code control thing called Radar. They're not even on GitHub.
Ernest, the other remote.
What's that?
The other remote.
Yeah. You think it's
Is this it?
No, that's the.
So maybe if you turn the handle on here.
You think it's?
I'll stand back here and see if I
Okay. So this is an important quote from the guy who actually invented the concept of smart contracts. Controls allow a quarrelsome species ill-suited to organizations larger than tribes to work together on vast projects. I call this, can't we all just get along? Okay? Come on, baby. Yeah. Now, is your head going this way or is the window going that way?
Yay!
Woo, let's give a big hand! You're hired. Thanks, man. Thank you very much, really.
That's perfect.
Is that better?
Yeah.
Muy bueno. All right. So, this is your second time to get out of this talk. Do you actually need a blockchain? If you want to do sub-millisecond statistical arbitrage at NASDAQ clearinghouse levels, you can leave now. Blockchain does not solve world peace. It does not cause unicorns to vomit $100 bills. But literally, the rest of this flow graph is, I believe, true in this case. How many people even deal with computational rules and contracts in code? Or just pure contracts? One person. Okay, I don't believe that. So, in your organization, does Jane Doe actually matter anywhere? Right? And is it a market-based approach? Every single company is a market-based approach with greater than two parties. Almost everything can be decomposed into a two-sided market. Okay? Statistical immutability. That's probably the most important thing. Distributed and immutable. All right? You can't change the record once it goes in. All right. So I'm going to jump into why we're evolving at PocketDoc to distributed ledger technology. In 2011, when we founded the company, I had just read Satoshi's paper. Interestingly enough, in the Satoshi paper, they never mentioned the word blockchain. That is something that Ethereum Foundation coined later on. And so almost the more I think about it, what this probability equation actually means is the probability of a payment given some asset, that dollar sign, and I want everybody to remember asset under consideration because it's going to become important later on. Given, and I don't expect anybody to know these. If you know them, great. But given the numbers associated with medical services and the medical service provider. So the combinatorics of a given asset on those numbers, almost any organization is the probability of payment flow. If you look across the continuum, okay? Now in 2011 I said, I believe that blockchain tech is going to be awesome in the future. Now, at that point, health couldn't spell API. Health tech could not spell API. I don't know if they still can, but we're making headway, right? So I'm going to set this up because the chain here is also it's a subconscious nod to blockchain, but literally any one of these areas in health tech is a vertical company, and none of them connect with each other. It's all siloed behavior. How many people have been to the doctor? How many people have filled out paper? You contributed to a $375 billion a year waste in paper by just the insurance companies. And 35 to 40% of all health data is in clear text, either at rest or in transit. Okay? Shop, book, and pay. So that's what the premise of the company is, shop, book, and pay. And we sat down and we said, holy crap, they can't even search correctly. You can't even find what you're looking for, as the song says, right? Clearinghouse. In a medical situation, in a pharma situation, there is absolutely nothing clear about a clearinghouse. You go check your eligibility, and 90 to 180 days later, you get back a bill, right? Identity and scheduling, pharmacy processing, payments, financing. And what we did was we built best-in-breed technologies and put APIs around these and created a Twilio Stripe-like platform so developers can actually build companies on top of all this technology. And this is all in real time. And we think in terms of graph theoretic constructs, okay, which is very important. If you think about how everything's connected together, you check eligibility, you want to know if you're authorized, you want to know what procedure is going to be happening, you want to know how much it is, you want to know when to show up, exactly all your information, and you want to check out and pay for it. Right? And then get prescribed some medication if you want to. And literally, we think of those. We drop this for the techies, and we drop everything down onto Kafka. We've experimented with every single. We're a polyglot house. We've experimented with every single graph theoretic construct, and this is also why we believe that blockchain is very important to the evolution of the company. Because if you think about it, every one of you raised your hand. Identity and health are borderless, anywhere, anytime, right? So I can go into excruciating detail about all of our endpoints. We have, just for everybody's edification, we have 5 main languages we support. Literally at copy pasta, C#, Python, Node.js. We even have a Haskell implementation. We got a Clojure implementation, so at some other time, if anybody's interested, we can drill down on that. But the record so far for implementing a application on top of us, we have close to about 1,000 third-party applications. We have about 95% coverage in the United States, and the record was by a virtual telehealth company, Doctors on Demand. In 2 hours, they wrote an application in production. They processed eligibility and claims in real time. Okay. All right. This is a version of what I call the cake diagram. There's layers, right? And so we have a patient access. Front end. This Angular based, and literally you can copy pasta what you want in there. We have modular applications that you can mix and match. And then some of the most unsexy computing known to personkind is at the electronic data interchange layer. It's a 19, so I'm going to show some examples of that later when we talk about the code on the smart contracts. We literally went line by line. Just the claims EDI specification is 637 pages. And we went line by line and rewrote everything for real time. And now we dropped everything down Just for level setting, because when I talk about this stuff, I never know where to actually cut. How many people know about Intel Saw 2 chip? Okay. All right, in the corner. You don't count. In the corner? You do? You do?
Just very little.
Okay,
Yeah.
cool. So, Ernest, where are we at? That could be one of the, I could come back and talk in detail, and we could actually run some stuff on the sawtooth chip. So, all right. So chain-wise, so if you're, by the way, this is not a blockchain 101 talk. We're assuming you can spell blockchain, you know. I believe that there's going to be a multi-chain environment. I believe there's going to be multiple chains for multiple applications and even multiple types of technology on chains. That does not preclude anything from being interoperable. There are several, at the chain layer, there's several interoperable technologies like the Interledger project, but what we're doing, our SBES or researchers, they have a completely different paradigm for health interactions, okay? CN is the consumer, PR is the provider, PY is the payer, BK is a bank, and EM is the employer. All of a sudden you start really looking at this and you go, wow, it fundamentally makes sense to stitch all of this stuff together, because I want to be able to clear out my HSA even before I show up to the appointment. Wouldn't that be great? All right, let's, why do we think we want distributed ledger technology or blockchain? Almost all industries have gone through this homeostasis. Extreme resistance to change. The banking industry went through it. The airline industry went through it. And as I said, the health industry is still having a problem spelling API. Literally, on the left side, and I think the one that, the two that are most important here, asset under consideration. Remember I mentioned asset under consideration is a smart contract. And then processing. Sending around Excel spreadsheets is not scalable, boys and girls. And interestingly enough, people talk about provenance of data all the time, right? Wouldn't it be great if you could have a trust model, a cryptographic trust model? How many people are still dealing on the left side at their company sometimes? And be honest, you know, slinging around email and XML is not cool. See, you're laughing because you know exactly what I'm talking about. And there are some ethical, some philosophical considerations. I mean, there are so many people. I've never seen the confluence. The only time I've seen a confluence like this was the early 90s when people were building real-time media processing systems, where everybody sat down and said, okay, we're going to have a common language, we're going to intercommunicate, and we're going to stand up some performance metrics. Because everything that's going to be happening right now is literally going to change the paradigm of us moving forward. And it really is about creating trust across industries. IBM believes that their 12 industries are going to run on blockchain in the future. Intel's creating chips. I just can't emphasize this enough. So reliable timestamps. When did something happen? Cryptographic security. I'm going to exchange elliptic curve cryptographic signatures based on some hashing function and make sure you got what you got, and we both agree from an algorithmic standpoint. Fully distributed replication. Everybody in this room has a copy. If it hits the fan, and it will, somebody's got a copy. Immediately stand it back up. I call it in situ disaster recovery. The one that I'm probably, the 4 and 5, 4, 5, and 6 are all interrelated. Code governing all transactions. No longer do you have No longer do you have somebody standing up there as the great arbiter saying, send this file now. Everybody says, we're going to agree right now that this is going to happen, and it's by consensus, and it's through cryptography. And I believe, as we'll get into, the value is actually in the smart contract. So, quick, anybody heard of consensus? I know it seems like a dumb question, but you were getting consensus on consensus. It's a very canonical argument here. We just built agreement. Everybody nodded. So remember the first quote that I put up. Some people think that algorithmic consensus is impossible. And when somebody says something is impossible, I sign up for it. And I mean that in the strictest sense. But what actually happens on a blockchain, and today we're going to be talking about permission enterprise chains, okay? Not complete anonymous public chains, and for good reason, because this is an enterprise application at the level that we're talking about right now. For achieving consensus with arbitrary faults, and I'm going to get into that because you never know when actually something is going to be an error or something is going to be fault tolerant at the time of engagement. There are many types. You could give an entire class just based on Paxos, RAF, proof of work, stake, existence. These are things that are happening right now. I urge anybody who is in the technical community to start studying consensus algorithms. And one caveat, all the stuff I'm talking about right now, from negotiation protocols to consensus to distributed systems, none of this is new, but it is the first time, just like smart contracts have been around since '94, none of this is new, but it's been the first time it's all been put in one bucket and everybody's voted for it. Once again, very canonical, consensus, right? We're going to talk about Nakamoto-style consensus, proof of elapsed time, which is basically like we go around, we spin the spinner, call the shot, and whoever wins, that's consensus. There's some very interesting mechanics on permission enterprise chains. You can get away with that, unlike proof of work. And the other one is, many people probably heard about PBFT, but basically you say you have multiple rounds of explicit votes, and the overseeing general from the general Byzantine problem says, yea, verily. Okay? So this is a very ugly slide. My apologies, I'm not a slideware expert nor a front-end designer, but I think this is a good synopsis of the three architectures that we have been very deep on. We went deep on all three of these. We have code running on all three. We've written smart contracts on all three. The middle one, Sawtooth Hyperledger. About 2 years ago, Tim, I wrote a blog saying this stuff's going to be on a chip. Isn't that right? Everybody thought I was crazy, which is not unusual. And lo and behold, Intel popped up and said, we have a blockchain chip. Not an ASIC mining chip, but something to accelerate distributed ledger technology in something called a secure enclave. A chip that has a secure enclave that generates a key that then you can distribute the key on is completely secure from a computational aspect. Okay? So, interestingly enough, you'll see the odd architecture out is Ethereum. That's turned into the crypto anarchist wet dream, and if they're not careful, even though there's the enterprise version, there's going to be a lot of hay to make, so to speak, in this area. The interesting aspects here is the permission chain, and what that means is, can I be on this network? Have I issued a smart contract that is cryptographically verifiable? And does it match the hashing and key functionality on the chip that I'm running? Okay? So in addition to having the streams encrypted, the smart contracts encrypted, and actually you are running against a secure enclave that's encrypted, and even the instruction set's called SGX. It allows for rights management at the assembly level. Now think about what I just said, 35 to 40% of all data in health is in the clear. Do you think there is any way we can even discuss security with what I just talked about on the chip? Is it secure? It's way more secure than a fax. But see, people don't want to deal in transparency like that. And this is happening across all industries. Smart contract language, we're seeing a resurgence. If anybody knows C, C++, Rust, which is basically C, we're seeing a huge resurgence in those types of languages. So PHP and Ruby ain't going to cut it moving forward. Right? Traditional systems are ungoverned. Even though you don't think about it, there's no cryptographic, historical, accurate record that is temporal based, that is immutable. Okay? This gives you provenance at the immutable level, meaning I cannot change it. Consensus being decentralized. We're basically all decentralized. Visibility, closed door. We're going to go make a decision and not tell you about it. Here, even on a permission chain, the entire network knows the decision. Spin it around, make the decision, everybody put it on the chain, on the transaction. Security. If everybody decides on a SHA-256 hashing function, it's completely known. Everybody knows the game, right? So this is where we get into really painful things. See, it's no longer, we're doing security, we're doing computational complexity. This is all about transparency at a level and nobody's ever seen before. What is the truth? What is the trust in the network? As far as I know, and everybody that I have talked to, and this is my statistic, 80% are in stored procedures in the SQL databases. Why? Because engineers are lazy. Don't trip. It's true. I mean, I've done little hacks to get around shit. And why? Why do you think that is? Because mainframes run. Mainframes run, and nobody wants to undo the thing that makes the money. Please don't take it away from me. But is it resilient? And does that dude or dudette that's 70 years old, are they going to die one day? Now, this is true. This is how far we plan in the future. Tim and I went on, and we were dying laughing. It was great. We went on, was it DICE? Remember we put out the bid?
No, it was work study, I think.
Oh, that's right. So we went out, and when I said I want somebody to write. It's not like we couldn't do it. It's just that you choose your battles wisely. I wanted us to wrap our REST interfaces in COBOL. Okay? Because all of our if it isn't obvious to everybody, all of our APIs that I discussed previously are smart contracts now. All right? So this is not something that's in the future. We are running now as we speak not technically over at 100 Calhoun, but it's actually running. And we could not find anybody to wrap a REST API code in COBOL. I even went out on the Twitter sphere and I said, has somebody built a COBOL to JavaScript compiler? I mean, we were doing all kind of crazy stuff, right?
Can you do TLS from COBOL?
Yeah.
Okay.
Yeah, matter of fact, IBM in their Z systems architecture, they actually have Fabric hooked up to their Z systems. Good question, though. And feel free to stop me. I mean, this is not like make it Socratic. All right, now getting down to some definitions. The funny thing about smart contracts is they ain't. Right? Yet. I'm going to get into some aspects around the self-amending of smart contracts, and it's a very bootstrap canonical thing we're going to deal with here. But safe to say that the important thing about that definition is credible transactions without an intermediary. Most all industries have been built on middleware. Okay? I'm going to talk about this some more, but if you're in the middleware kind of business, I was on a panel recently where the former CIO under Obama said, if you are in middleware business, please go find something else to do. You're getting ready to get washed out. Because remember, we're running on a chip right now. Our company. And it's a health-based API company. I mean, there's a lot of downward pressure happening right now in the industry. And it's nothing new. Okay? But remember, do people think that's an important thing to actually have it go down in the industry? Cryptographic agreements in real time. Instead of going in and saying, hey boss, can you sign this for me? Right? So reasoning. Expressing business logic as computer programs that self-amend. Ted, what does that mean? That sounds like some kind of Star Trek stuff. Or Black Mirror, which I do enjoy that show. I'm going to get into it, but genetic programming is also going to come into norm. Once again, nothing new. COSA started that at Stanford in '78. We're very big on it. Representing the events which trigger that logic as messages to respective programs. I no longer have to pick up the phone and give you a call, right? Once again, think in terms of disintermediation, contractual cryptographic agreement, and consensus across multi-party engagements. And here's the important thing. In a past life, I'm very sensitive to this. I spent a lot of time on the Hill doing technical policy for a company in Redmond. And thou shalt not regulate technology. You have people go, well, what about security? Or what about Makolo? Or what about, some legislation, right? There's no possible way that legislation can keep up with that screen right now and that code. So when you're bringing new technologies, be very thoughtful, because realize a lot of people's lives are built around that whole scenario I just discussed. So we have to be very thoughtful when we're discussing this. Like explaining to people what SHA 256 is, explaining to people what homomorphic encryption is, et cetera, et cetera. I'll get into that later. Wouldn't that be nice, instead of signing a paper? I found out recently that in a legal trust environment where trust is explicitly meant in a will form where somebody bites the dust, you have to physically sign a piece of paper. Now, I know companies right now, as we speak, that are making that go away. They are arguing the point that a cryptographic signature based on the identity of the person is way more secure because of a forged signature. Okay? So, with the exception of very large files, like an MRI scan or something, voluminous, most everything else will be placed on the chain. Okay? It doesn't really make sense to have an MRI scan, and it's not designed that way. The payload's not designed that way if you looked at any of these architectures. But remember, this is about Making sure that identity is linked to a smart contract and is immutable, and that transaction cannot be changed from a cryptographic standpoint in a temporal fashion. And like I said, you can have signed code. Are you on the chain, and the secure enclave generates the key to even allow you to compute on that chain. Predictability. Wouldn't it be great if we had contextual predictability in our companies? And this provides, because the smart contract is computational in nature, it's a set of rules that say I agree to something from a computational aspect. It would be great if I had contextual predictability. And here's the kicker. The rule sets can be greatly simplified. Like I over and over, I go to some of these people when we're talking about like, and I'll get into it later, but like adjudicating a claim. Oh, we got too many rules. Just like in, anybody see Amadeus? When Salieri goes, oh, there's too many notes, or the king did, or whatever. No, everything's right where it should be. You just don't get it yet, right? So, when you take them off to the side, go, I know how to do this in a much simpler fashion. Tell me in English. I'll write it down. And the great thing about that is it also makes a frictionless environment. What we're trying to do at PocketDoc is take all the friction away from a helped interaction. Okay? And think about it in your business, reducing friction. Everywhere there's friction from a computational aspect or a manual aspect, you can almost take it all away with this engagement, with a smart contract. So far everybody kind of getting where I'm going with this so far? Everybody? Yeah.
So you talked about this like replicated nature among, you had this diagram earlier of these different entities, employers and providers.
Yep.
Everybody. So conceptually, how do you think about confidentiality?
Yep.
And not even just of the record, but of the existence of it, right? Like I might not want my employer to know I went to provider A through Z.
Yep.
I just want to know that they owe somebody $10,000.
You as, and what's your name?
I'm Ted, also.
Awesome, great name.
Easy to,
I'll be Theodore right now.
yeah,
Okay.
yeah.
Okay, keep going.
So in this replicated model, how do you ensure that not all the players, I'll put it the other way, how do you ensure that the players are only scoped to what they ought to view as the subset of the data?
Okay, so from an access control logic standpoint.
Access control, confidentiality, secrecy.
Okay. Yeah, so
They're all trusted, but only within their scope. You know?
exactly. So within you just so literally with respect to secure enclave technologies, you can actually apply to that stream access controls that you can be in control of. Like when somebody says, "Hey, can I have access to your personal health record?"
Yeah.
Okay, Ted. So I can have access to. Why is that employer that I don't know trying to get access to my personal health record?
So when you talk about secure enclave, like I think about it as like signatures and encryption, right?
That's one part of it. The secure enclave is actually a computational process that actually generates a private key.
Yeah.
And you are in control.
Like my phone has a secure enclave.
Exactly.
Of a type.
Exactly.
Right?
No, it definitely has.
I mean, it's a Pixel 2. So
Yeah, it definitely has a secure enclave.
I mean, it's a different type of secure enclave than the one you're talking about.
Nope, it's one and the same thing.
Oh, okay.
Yeah, literally. Thank God.
Okay.
When I say secure enclave, that is on the chip generating a private key. So you just answered your question.
Yeah.
He's not going to be able to get and I'm not going to let him get access to my key to match that record right now.
So because it's encrypted though, it like the crypto text is still visible to these other entities, right? Is it?
No, it is not in the clear. The crypto.
No, yeah.
Yeah. So there, I'm going to mention at the end.
All right, we'll show it.
Yeah. So there are techniques where you can do analytics, but you can't actually see the encrypted text.
Right.
Yep.
You're talking about homomorphic.
Exactly.
Right?
Yep.
Okay.
Very good.
Yeah.
You've done your homework.
Okay.
Where do you work?
GitHub.
Okay. Great.
Yeah, I was at Google and
Awesome.
I actually presented here last month.
Awesome.
We'll chat later.
So here's our assumptions on the, well, you guys run a Merkle tree, so
You talking about Git?
GitHub's a Merkle tree, so you guys, I mean, that's, with the exception of the chip layer, this is essentially a blockchain at some level, right?
It's not immutable.
No, I said at some level, I didn't say it
Yes,
was.
there's a lot of asterisks.
Yeah. Okay, so let's get back on track here. Each node represents its identity as managed by a public address on the permission chain, to your point. Each node verifies that the other's entity address is its own version of the permitted permission chain. That sounds kind of redundant, but can you actually be on that chain? Each node sends a challenge and says, okay, what are you going to do with this? And each node sends back a signature. Said, yep, we're trusted, providing the ownership of the private key corresponding to the public address on the chain. And if either node is not satisfied with that result, completely binary. So this is basically a two of two multi-signature algorithm, and that's exactly what I just ran through in English. D sends a list of IC inputs with assets. Do you want this? It says, okay, yeah, I want that. It creates a transaction set. Okay, we're getting ready to put this down in a mutable form. We're going to create a time lock transaction. We're going to say, okay, right now, in as real time as we think, we're going to put a transaction set. If you agree, you sign it with elliptic curve cryptography, and then the updates are sent to the network.
I have a question. What is right now two-party signing this?
Well, as close to a timestamp as humanly possible, or computationally humanly possible. Humans don't really think that good in real time right now. So, but I was being kind of facetious there. But the timestamp of the immutable temporal ledger, and the timestamp on that, based on the consensus model. Okay, good question. Can anybody read this?
Oh, it's fine.
Huh? If you can, I want to hire you. That is how you check eligibility. That is how you check claims. That is how you do anything in an electronic data interchange format.
I shouldn't have put that asterisk in my kid's name.
Yeah.
Rolls out the tables.
That's right. You didn't get paid. How many people can read that? You lifted a lot, you hurt your back, you got to go to a doctor, and there's your insurance. It's the same code. All right? This is just JSON. All right? So people go, oh, it's impossible, it's too complicated. Now, a smart contract, the next slide I'm going to show, comes up a level on the client side. Now, while that's not more simpler, that is an agent that interacts with the blockchain, the sawtooth blockchain, to say, I'm going to pull out your behavior and your roles. Remember when I said roles? We're actually going to pull out the behavior of your smart contract and allow you to compute as this is a complete agent-based representation. It's not a single file. It's not a single call. It's actually going to be your agent on the system. Okay, so we just abstracted everything way. It's going to emit JSON at some level, but guess what? It's computing on the behalf of the entity. All right. So, does anybody heard of game theory other than Uno? Man, Uno gets terrifyingly aggressive sometimes. Why do you think? What do you think that I think game theory is important on the blockchain in the context of smart contracts? Anybody? There's no wrong answer.
So the entities involved are inherently antagonistic.
Yes.
There are zero-sum aspects
Yeah.
involved in
Yep.
their transactions, right?
Absolutely. And they don't really trust each other.
Cool.
Good answer. Oh, one aspect here is rational decision makers. Nobody makes a really
No.
rational decision.
No, impossible.
That's right. Good word though, impossible. Okay. And like Ernest said, literally I can come back, run some code, we can get as deep into this stuff, but I didn't know the level that we wanted to go, so we're just going on high level stuff right now. The two models in game theory that are most studied are normal form. So basically you have a matrix with squares saying player 1, player 2, and then what's called a payoff matrix. What happens when you make the decision, right? The other form is called extensive form, and it's basically a tree structure. All right. For those mathematicians in the audience, this is kind of how I think is tuples. You know, tuples and vectors. You take a list of entities and index on I. So SI is the set of all strategies that are available to player I, and then you map that to your utility function. Johnny von Neumann, his biography is great, by the way, but Neumann and Morgenstern wrote the Bible on game theory. Go get it. It's amazing. The utility function is actually named after the inventors of game theory. Okay? Based on this mathematical behavior, utility is what I agree to, what I'm going to converge on. So think about it. I have a secure network. I have a consensus model. I'm going to agree. And that utility function is what I'm going to converge on. Everybody starting to make sense now where this is headed? We're sort of peeling back the onion. Anybody heard of prisoner's dilemma? Okay, this is a cool. It's a very simple case. 2-player, 2x2 matrix. Very simple, but it can be extended. But this is basically like Lowe's and Home Depot having at it on where's Home Depot and Lowe's around here, Betsy? What's the road?
Well, there's one on Northwoods Boulevard right across the street from each other.
Okay, and then I think there's one on Glen McConnell or something like that.
Yeah, that's true.
Okay, so Glen McConnell. Why in the world would Lowe's and Home Depot? Why, as soon as you see a Lowe's, you see a Home Depot, right? Why is that? Because their pricing function is a classic application of the prisoner's dilemma, which I'll discuss in a minute. But put that in the back of your head. Pricing functions, agreeing. So two people arrested. Ted and Theodore are arrested. Okay? You haven't really done anything wrong, have you?
Oh, no, nothing's wrong.
Good. That was an awesome answer. Plausible deniability. So each can either confess or they both can keep silent. So what happens? No matter what the other suspect does, each can improve their own position by confessing. I'm going to show you why in a minute. If the other confesses, then the other had better do the same. What do you think is going to happen? I confess. Ted doesn't. The hammer's coming down on one of us, right? If the other keeps silent, then that one better obtain favorable. He's going to obtain favorable treatment, right? Because he's going to out the other one. And no matter what, in that situation, the hammer's going to come down. This is the terminology in this case is called dominant strategy. Self-interested agents. I showed you an example of an agent. Almost all aspects of game theory evolve to dominant strategy at an equilibrium state. All right. Here's the payoff matrix. Think about it. Smart contract rules. There were some really easy rules I just went through, right? Think about pricing. Think about what happens to these prisoners. Think about if Lowe's posted a price And Home Depot looked at it and said, okay, I'm either not going to do anything or I'm going to cheat on the price. Okay? It's also called, the vernacular is called tit for tat. That's where that actually came from. The boundary conditions in the two corners are not good. Dude, don't say something, please. Let's get out of here. Right? Make sense? And literally, the great thing about this is this brings in what behavioral economics. This really allows you to start computing the behaviors and the connotations and the context. Equilibrium occurs when each player takes the best possible action for themselves because in the action of the other players. Remember, we have a utility function. It's usually gradient in nature. In this case, it's not gradient. It's very simple. A bad outcome. Prisoners could do better by both denying, but once collusion sets in, each prisoner has an incentive to cheat. How many people have ever been in this situation? For something like it? Not in a jail. And if you have, you probably, God, what's the other person going to do? Complete, like, what are you going to do? I wonder how much they're going to charge. I wonder if they're going to commit this code. I wonder, And for the graph theorists and decision tree people and people who run trees for their software, there's the extensive form, right? Matrix form, normal form, extensive form. Everybody with me? Starting to get simple now, right? All right, here's where it gets weird. If game theory is that, there's something called mechanism theory. And by the way, timing is everything in technology. If you remember, I said we want to do blockchain in 2011. People can't even believe we do real-time eligibility checks right now. It would have made no sense to go build a blockchain architecture in 2011 for help, right? Mechanism design is something that's been near and dear to my heart for about 7 years. And what that literally means is looking at the temporal time steps in the immutable ledger and pulling out the rules. You pull out the payoff matrices based on the behavior of n parties. Now, historically, because of computation and consensus models, it was considered MP in some places, but now we're starting to see that it's actually being computed. Professor Silvio Macaulay, write that name down. He's probably done more he's a double Turing Award winner.
Wow.
Gave a great presentation at MIT recently. I attended, and we had a long discussion about creating real-time incentives.
What's his name again?
I'll probably screw it up. Silvio Macaulay, Professor Silvio, and he's published.
Algorand is the,
Yeah, Algorand is his current architecture. It's a one node blockchain. It's basically a straight hashing function. But and once again, this is I can go in any one of these slides. I can go super deep. So if you guys choose a subject, I can come back. But mechanism design is kind of like, for those who've ever used rules, it's kind of like going, God, I don't even know which rules to code right now. It's kind of like looking at the statistics and going, okay, I have a rule set. It's like feature extraction and machine learning, very closely aligned. But see, once again, outcomes according to players' dominant strategy. Okay? So why is that important? We had a little discussion about parties. Given a smart contract, given a computationally cryptographic agreed to contract, we have a negotiation. Why? Because I don't trust you, I don't like you, but we have to do business together. Negotiations assume strategics around choice. Prices are choice. what products to release or choices, when to release the products. Well, some other examples like that from a business standpoint. I mean, anything.
Healthcare is huge because you encourage people to take healthy lifestyle choices, or you give them drugs.
Yep. That's an interesting. That's true, but if the hot light's on Savannah Highway, you're going to get a Krispy Kreme. But you're exactly right. So, whether I pay today with same-day self-pay, whether I pay tomorrow with same-day self-pay, or I use insurance, right? Go.
Do you see this as a mechanism of transforming like game theory sequential games into forcing them to sum 180 for like Casey and bargaining?
Are you?
Externalities?
You're jumping ahead in the slides, sir. It's called repeated games. Yep. And so I'm going to actually show a flow graph of evolutionary game theory and how you do self-modified code. Okay. Great question. Yeah. Does that answer your question?
I see. Like if you could reduce the cost of transactions, then all of a sudden you can actually do Casey and bargaining and have an efficient outcome.
Is completely in that area, because remember the can-has blockchain slide? Reduction of cost. Remember, take all manual processes out of the system. Any manual transaction, like go back to wherever you came from and say, wow, does this apply here? Can I do a computationally exact cryptographic agreement that is in real time or close to real time? I mean, because people talk about healthcare, they go, well, what's the throughput? I got 90 to 180 days for a claim. I got forever. All right. Utility functions. What do you got? What do you want? What do you got? What do you want? These utility functions are how we attempt to optimize. A professor in a land far away, he wrote The Art of Computer Programming. He told me in a class one time, he said, Theodore, in life we're always optimizing. And I didn't really understand it then, but now that I'm old, that's all I go around and think about. It's like, man, that's very prescient. Like anything you do, driving a new place, going to a new store, trying to code, trying to write a report, we're always optimizing. Optimization implies equilibrium states. Are we at the bottom of the barrel? Have we agreed? In the next case that we evolve to from a bargaining standpoint, right? Now, philosophically, I will tell you, and a lot of many of the behavioral economic professors out there, there's a lot of discussion now because we are in a world after having, let's see, 2000. What year are we in? 2018. So 9. I'm not good with time. So 9 years later, right? People are trying to really decide if the markets are, if there's such thing as equilibrium, right? Whole concept of Nash's equilibrium states are in question. Once again, another great biography. For just completely unrelated is Claude Shannon, von Neumann, Turing, and Nash. Read those if you are a student of technology. Go read those autobiographies. They're astounding. And if you want to feel really stupid, go read them. It's like I haven't done anything. I'm going to go pick weeds. Equilibrium states assume agreement. Utility agreement. Have we reached agreement? Negotiation. Once again, I showed you a running example of a software agent. See, that freaks people out. I'm going to have a software agent negotiate on my behalf? Well, yeah, of course, because it's going to negotiate faster, and it's cryptographically secured, and I just gave it the rules.
Yeah.
Go ahead.
How do you make sure that the software agents the bias is not built into them? Because you've got humans building them, right?
Yeah, that's a great question. Many cases, and this is where this is non-trained agents at this point. But just like a buddy code check-in, many companies are actually having a second and third pair of eyes on some things that actually are out there negotiating on your behalf.
Okay. So, and are they also consulting with like neuroeconomics, economists? Because those
You hear me talk? Yeah. This is so the great thing about blockchain, it is bringing together the lingua franca of several industries. So rational agents. A great book, if anybody is interested, is called Agent Zero. It was written by a doctor and neuroscientist out of Johns Hopkins. Anybody remember Logo, that language? It was written in NetLogo, which is I can come back and show you code examples written in that. But he starts with the actual serotonin and oxytocin levels that he's modeling as a function of agents. Great question. So this is how serious people are, right?
Great. Because it's really kind of scary about how irrational we are making decisions.
That's a whole other class. But yet, was it this week or last week when the 2 empty rocket canisters landed backwards in a synchronous fashion? Was that this week or last week? How many people were like amazed? How many people went and picked weeds because they felt dumb? I always go back to those types of behaviors. Go back to the Shannons and von Neumanns and go, okay, we can't cripple the result because of what we may think, because what we think is possible, these software systems are going to start evolving. Like the deep learning stuff from Google, actually, I was reading a great paper, int A, int B, right? The Google deep learning machine doesn't have to have A or B, it just has to have int. Oh, wait a minute, what's it doing? Well, I guess it knows, but I don't know what it's writing right now because it's a stream. Right? So those are to answer your question. This is really pretty much all our wetware does every day. It seems kind of sad, but let's not get too idealistic. So, to your question, they're capable of independent action on behalf of its user. I'm lazy. I want to set a bidding functionality on eBay and have it bid for me. Right? Figuring out what needs to be accomplished based on objectives. Okay? Agents, once again, rule sets of the asset under consideration. I'm going to keep going back to this. Modeling the population dynamics of different entities. Okay, looking at the behavior of different things and how they converge. Genetic programming is not genetic algorithms. Genetic programming is actually taking code and actually having it modify itself. Genetic algorithms are converting dynamically to a utility function. They're closely related, but this is a GP problem. Yeah. So, changing negotiation goals would mean if you really change the negotiation goal other than a price, you have to change the code. This is where the self-amending comes in. Something that we're a big proponent of, everybody talks about Turing-complete systems. You can do anything with a certain finite set of instructions. That is literally what caused the DAO hack. You know, it started and it went turtles all the way down, so they say. And if you have a finite set of instructions that are capped at a certain behavior, you can't get there. But the secure enclave technology helps. This obviously, if you have self-modifying code, it adds overhead, right? And this is why it predisposes at least what we're doing to hardware implementations, a la the Intel chip. You know, ARM is getting in the game, and you know, I'm sure AMD and NVIDIA and everybody else will. It's kind of like the mid-90s when everybody was making signal processing chips. So, this is what here's the game theoretic portion, right? And the outside is the genetic programming portion. And it really is that simple from a concept standpoint. From a coding standpoint, it is really difficult to test these systems because, like from a GP standpoint, you may have, like if you're doing symbolic regression with this polynomial, it may spit out all subtractions. You go like, what in the hell? It works and it's optimized. But I don't understand it. Well, you're a human. But the result's there. You guys see the disconnect? Just because we don't understand it doesn't mean it's not correct. All right. So I'm going to switch gears because identity is probably the number one most important thing to us and to blockchain. What you do is who you are. I'm sorry to say that, folks, but literally what you do is who you are, at least to behavioral economics. Okay? So, there's something, how many people do like identity matching at their companies? Okay. This is not like a straight heuristics match where you literally say like a patient index or something like that, right? This is not that. This is based on context. So colloquially, you have let's say you have 4 identities in a temporal fashion, right? Assuming time is linear, we'll keep it simple. You are born. You have a social security number. You maybe have a bank account where you learn how to manage a checkbook or whatever it is. Then sometime in the future, you have a stockbroker account, and then then you have a health ID, and then sometime in the future you have a death certificate. Let's say between those entities, the context changes, but those are 4 major identity events. Everybody agree? Like those are really like, holy shit, that's important to me. Let's say I'm down on King Street. Today is Friday. I'm going to go do the black barefoot crawl, as they say. That is the most hilarious thing I heard. I was talking to this woman, and she said, I can tell who went out Saturday morning because in yoga class they pick up their feet and they have dirt all over them. Anyway, let's say I'm downtown. I want to be anonymous, 21, and the ability to pay. I don't want you to know what I'm doing, but I do want to have the ability to pay. Right? And I want to be over 21. The other end of the spectrum is I went out Friday night. During the day, Saturday, I started feeling bad, and I didn't get my flu shot, and I went out all night drinking, and I show up at Roper Hospital with 105 fever. Please, immutable ledger, tell them everything about me. Those are the 2 contextual bookends. Everything else between there is a gradient, right? And these are the behaviors. So, what we sat down and did was we said, from a blockchain standpoint and a doc-chain standpoint, what we're doing in health, what really from a contextual standpoint do we need to compute? So this equation is actually a query mechanic on our system. Given the probability of a certain query vector, given the current identity provider, because this really changes things. Right now, ProcketDoc's running across about 4 billion entities and by consensus. Okay? The great thing about this, you can read, so IDP is identity provider. There's a gazillion of them out there. And the cool thing in the future is, if you come up and say in the future, Ted, my data is so good, I want to sell it, I want to change it for a utility token or a crypto asset. You're like your health data. I'm going to let you have access to my health data for X amount of dollars. Once again, a negotiation situation. Might be a boundary condition, but you never know, right? But I want to let you know that I may have been at a bar downtown. How much is that worth to you from a crypto asset standpoint? Because it's all marketing and behavioral economics at this point. The cool thing about this is, given all the identity providers out there, this W transpose can actually compute the quality if I add another identity provider to our consensus network in a temporal changing fashion. I want everybody to think about that. I have a bunch of identity providers that are, and by the way, in the future, your social security number and your demographic data, they're all out there somewhere. Stop worrying about it. What you do is who you are. This query mechanic is a probability. You say, well, Ted, what about 100%? I say, your company doesn't do identity matching right now at 100%, and if it does, you are lying. Most companies have about a 75% accuracy on their match. And contextual too. This solves the contextual process. Ensuring that only the minimal amount of information about an identity can be used for any given transaction to your ACL.
Yeah.
Because given this equation, it's based on the provider as a function of the current query. I'm only going to give you access to that certain portion. Yes?
So who's the arbiter for who gets access to what in this model? Is it the consortium of entities that are in the chain? Is it the individual that says...
Both.
Yeah?
Both. Perfect question. Permission enterprise chain. You know, these are companies like check Interpol. Literally, we can go next door. I can check and see if you committed a crime. I know you. But you know, we check Interpol and crazy stuff. But to your question, the outer layer of the application, you can possibly say, if I'm doing a trade on a crypto asset for your data, I can say, yeah, sure, they can have that information. But most of the time, right now, this is done in a permission chain. Great question. All right.
But how does it, I mean, it seems like that could get pretty complicated though, from the standpoint, let's say, if you think about teenage girls,
Yep.
especially,
Yep.
who want to be sexually active, but don't want their parents to know,
Yep.
and want to be able
that's
to
true.
use, you know, like a Planned Parenthood or a healthcare provider, but that could be reimbursed through their parents' healthcare.
Remember, my chief scientist. You remember the thing Target did where they predicted the woman?
Yes.
The one was he did that. So, what you do is who you are. This is almost, if you really, I don't want to get too metaphysical here, but it's almost like, okay, I better think before I jump. So, the level of privacy is an issue, but once again, we PocketDoc is dealing right now in the level of enterprise health applications from an identity standpoint. We've had other companies want to reuse this for ad tech, obviously. And once again, that's the reason I'm beating so hard on the cryptographic importance of this. This is, I mean, you know, from a social engineering standpoint, it makes it very difficult because everything's encrypted. Yeah.
So just adding another level, if I'm sharing my medical information with someone, or
Yep.
my whereabouts with someone,
Yep.
is there a time aspect into it as well? Not when I did it, but how long can they
That is so that W transpose also is on a temporal fashion.
Okay.
You have so this, okay, let's take this to something that's very near and dear to my heart. We literally make the concept of an eligibility check go away unless you have a life event. Think about what I just said. Like, I just have a token asset in my wallet, right, from that query. And doctor, you can have it for 1 day. You can have access to the information for 1 day. Or somewhere on King Street, you can have that information for 1 hour. Economics 101, make something important, you take it away, right?
Mm-hmm.
So to your point, the concept of eligibility completely goes away because like right now, if I don't have a life-changing event, my eligibility is going to be the same until I change sometime in the future, right? Great question.
Well, then it brings into the account of preventing copy right? So if I give them access, can they take the data and then put it somewhere else? So now,
You can revoke. You can revoke it in this model. Yeah. Because remember, the application stack is also one and the same that runs on the network. Great question.
But there's nothing that can prevent it from going from one person has the value for that moment of time to be able to send it someplace else.
They could verbally probably tell somebody. I could think of but think about what we're dealing with from a real heuristic standpoint of most companies. Spreadsheet, paper,
Yeah.
you know.
But when it comes to identity and like for marketing
I
purposes,
guarantee you, yeah. Oh, got 5 minutes? Okay, we can drill down on this.
Yeah.
But that data stream is encrypted in the application and is only available at that time in the application based on the secure enclave of the chip.
Mhm.
Completely locked. Let's see here. For those interested, this is our stack on AWS. You know, we got the whole elk stack. We're storing very large things in the IPFS, interplanetary file system. I spoke at this at reInvent. I'll go quickly on this. Let's see. There's the specs. You can spin it up one click. We're also running on Azure and Bluemix as well. It takes about 2 hours to deploy a node validation. And that's from the enterprise standpoint. Key management. I really want to go through this because this is just real quick. Secure enclave generates a key. The key is sharded, and here's where the importance of the identity part comes in at. We shard that key across the entire network of identity providers. Okay? And here's the kicker. We lock the identity provider in that network. We know who's got the shard, and if you throw your phone away, we can recover the key as a function of the network. So that completely revokes, that's a revocation process right there. Oh shit, hit reset. And every transaction, we do that process behind the scenes anyway. We can have a whole class on this. There's actually what I just said we did real quick. Here's kind of our roadmap. We can do a one-click deploy now. Contextually relevant identity is going to be available by the end of Q1. W3C verifiable claim compliant. That means the Department of Transportation, the Department of Treasury, and DHS can use this technology. For those that want to go trade their brains out, we are ERC20 compatible on our crypto assets. So remember I said we got about 1,000 third-party applications on our stack, right? We've made a crypto asset framework on Hyperledger Sawtooth, so you can go do your own crypto asset in a secure fashion. Right? All right. Now here's the cake changed, right? Because remember I talked about all this stuff, and now all of a sudden we got a crypto asset framework. We got the docs chain, but now we have StatArb. We want to negotiate through cryptographically computable smart contracts, right? And that's our stack now. And so on the right side is where we can enable all the stuff I just discussed. She who has distribution wins, so we built an alliance. It's a request in the back corner. That's some of the players. Some of those names should sound familiar. We've got about 54 companies involved. The use cases we're working on are identity by consensus, something called autonomous auto adjudication. If you click your heels twice, you go back to Kansas. And what that means is I'm going to close the accounts receivable window down on a claim to a day. That's the goal. You leave, you know exactly what you paid. Supply chain provenance. We own a pharmacy. We own a pharmacy processing API. We can work with Merck and other companies and tell you the provenance of drugs and go the last mile and distribute them. That's a huge thing. Supply chain diagnostics. Siemens and GE's up there too. Pre-authorization. I don't even want to go in if I'm not authorized for the thing. the chief medical officer of Sutter said, Ted, he put his arm around me on a panel. He said, on a panel discussion, he said, Ted, you solved that. We can all go home and everybody clap. So I'm going to go out on the proverbial impossible limb. Let's say that disintermediation will occur at the middle layer. Cryptographic, we've done some techniques in homomorphic encryption, which is doing analytics on encrypted data. It is extremely slow. Behavioral economics will come into play. What you do is who you are. Evolutionary computing will finally take hold. Chip architectures will evolve. You will have, it is my bet, you'll have to learn some form of statically typed compiled languages. And this will become the new normal. Let's hope that Black Mirror will not actually happen. That's another, yeah, I had 2 slides in there, sorry guys. And then here's some references. Great evolutionary programming Python library, works unbelievable. This is named after Robert Axelrod, who did repeated games. Somebody was asking about repeated games. 2 great libraries. Stuff for us, and then we've done a ton of commits to the core of Hyperledger Solitude. That's where to find me. Was that cool? Ask me anything.
A couple of questions real quick. And again, what I would like to do, based on this presentation, for those of you guys on the technical side who like to do a deeper dive, you could put back an email into Fridays at charlestondigitalcore.com. Very topical, some topical things maybe, for a little more of a private session, a non-promoted, session basically, specifically to about 20 folks, that can get into a deeper dive in some of the stuff so you guys understand it, for the technical set in the room. But certainly appreciate you being gracious at this time. I was just sitting over there telling Chris that this was, way past my pay grade. It was just like, but fascinating stuff.
Yeah, and Ernest, thank you. Let me emphasize, I don't deal in vaporware. Anybody around me who deals in vaporware, they can go somewhere else. I mean that in a strict sense. And, we have stuff running today. We got proof of value contracts with several large companies, and it's all happening now, and it's super exciting. It was funny, I talked about rules a lot. Right now, she who sets the standard wins, because right now, and I don't mean standard in like a showing up at a meeting standard, but like you take your best shot and get something done, that's going to set the water level. Yes?
So looking at this and just my experience with databases in general,
Yep.
this is essentially like an AP database, right? But in the base of constant partitioning.
Mhm.
So I'm just wondering, I see a lot of these databases that were formerly AP certainly building
Yep.
boundaries to add C as in cap sort of back into the equation.
Yep.
Because a lot of developers and a lot of database admins, et cetera, can't reason about things like eventual consistency. It's like,
Yep.
So we sort of glossed over that slide. We talked about Paxos and RAF and
Yeah.
what is simultaneous time.
Yep. Did you see the first slide that I had if you needed a blockchain?
Yeah.
Yeah, so I mean, if you're really dealing in sub-millisecond computation, and there's not too many people that are really dealing, because right now we're looking at 1,000 transactions with the computational construct and consensus. We're looking at about 1,000 transactions per second. To give you an idea what that is, 600 transactions per second will get you all the transactions for a year in health, which is about 20 billion transactions. Okay? So we're looking at, but heuristics and metrics, like right now there's no whetstone for blockchain. But remember, this is at the core level the same constructs as the distributed replicated database. Great question. But with that, maybe that could be a subject and come back. You had a question?
Yes, do the technologies of blockchain and deep reinforcement learning go hand in hand?
Completely. Yeah, I mean, so it was fun. About 3 years ago, I was interviewing this guy, and he said, And I was telling, so what are you into? He goes, oh, deep learning. I said, like, multi-layer back propagation networks. He goes, no, the new stuff. I was like, I missed the memo that neural networks changed. So yeah, there's some companies out right now that have written agents that are automatic. Most of the stuff that's traded on GDAX right now is RNNs. So good question. Yes, sir.
From like a staffing standpoint for people in this space, like for people like you and other companies working in this realm,
Yeah.
what's your like wish list of like people that would walk in the door to contribute?
They're nice.
Yeah. I like that you started that way.
No, that is a great question. So
You make a good point about our industry, by the way, by saying that.
I
Because a
could-
lot of people
I-
are smart and then not that.
I could give a whole class on that. I'm more interested in actually what your hobbies are, to be honest. Because I want somebody creative, and because eventually the code's going to start writing itself, and we want creatives and technical people to really think about how to optimize it. And so we look across many continuums. I will say that I think this is, it may not seem like it, but the UI, UX design of the identity functionality is going to be extremely difficult, to your question, to a bunch of other questions. I do think that knowledge of chip architectures and lower level languages are going to become important. You can't get away, you can't be scared of summation signs. I mean, you can't be scared of summations and probabilities and stuff like that. And the other thing, on a very serious note, if somebody asks how something works, if somebody doesn't stop and try to explain it at multi-levels, they don't belong in the game. I mean, I could have made this entire presentation where nobody understood it. What I was trying to, bridge levels, right? And that's where it's at. But I think you got to know lower level languages from a technical construct. You can't be scared of CLI.
You say that from like a safety standpoint, the way that Rust talks about safety.
Exactly.
Or performance is part of it, but more about safety.
Yeah.
Okay.
I mean, that's yeah.
Okay.
You mentioned that language. That's it's been around 10 years, but it's going to get used heavily now. Great question.
Thank you.
Any other things? Was it cool?
Yeah.
You guys got any ideas for what you want me to talk? I'm just real quick, Ernest.
Absolutely.
Any one particular subject you guys want me to go deep on? Yours is database performances, and probably, right?
Well, I'd like to know more about blockchain and how you achieve any level of consistency in the face of partitioning, how eventually you resolve split-brain scenarios across the blockchain.
The consensus mechanics, and that's probably the number one. That's why I had a whole slide by itself. So, consensus mechanics was another one.
Genetic programming.
Okay, GP.
Pete Woodall just left, and he had a couple of them as well.
Oh,
that
cool.
He wanted to do so. He'll ping me. He just said he'll leave, but he was, he said
Did you dig it?
basically what his argument is basically the technology is unbelievable. Now for the audience, basically some of the folks like those in terms of how brains are thinking, how can you monetize? How can you build a company based on the technology that you're developing and some of the that kind of thing. So
Don't you just make an ICO and trade it?
so it's going to be. So I think he.
I mean, that's a whole other agreement. Whether you do a token offering or an ICO. I mean, that's a whole other class, right?
Exactly. Yeah. So well, something tells me you'll be we'd love to have you back based on what.
That's cool.
Yeah.
And.
Yep. You got a question?
Oh, no, just the behavioral economics, because that's a huge field on its own. And I mean, we can't also deny that Google a few years ago, remember the whole incident where for black men, they were showing gorillas?
Yep. Yeah, this gets into the ethical standards for machine learning. Yes.
Is any part of it like open source? We could kind of dig into it.
Oh, those links. Yeah.
Okay.
I mean, all of our, all the go to Hyperledger. Like just search on Hyperledger blockchain. Fabric is open source. Intel Sawtooth is open source. If you go to our site, we got all the white papers up there on the stuff I talked about. And we got our mess around. We got client libraries. You can stand up a mock test data and bang on it.
So is your solution just kind of like a conglomerate of these open source tools, or is there any sort of like, so when you stand up an AMI, for example,
Yeah.
right?
Yeah.
So what are you essentially standing up? I mean,
Oh, from let me go back. The beginning is where what did Lewis Carroll say? The beginning is where everything starts. Thanks, y'all.
Thank you.
Okay, so when you stand up an AMI, you get all the back-end Hyperledger Sawtooth blockchain technology, but also you get access to our identity functionality and all of these APIs from a testing standpoint.
gotcha.
Boom. Yeah.
Just on, the kind of going on, we're beyond the database and the architecture and then do we need blockchain?
Yeah.
I'd like to hear a little bit, if you're coming back, about, making the business case and your experience in and around that.
Yep.
I work in a lot of client services environments, so in the room, where have been the successes, what's resonated,
Yeah.
with the business side of the house?
Yeah, I mean, it's actually out of control.
I mean, they hear blockchain, everyone gets excited, they're like, yeah, we need,
this is,
they said, oh, we have XML. And
This is really, yeah, this is really from the use cases I discussed. It's just from implementing identity by consensus it is literally out of control. Sounds like right?
Do you guys license, like, if you run a network now and you need smart contracts, you need identity
Yep.
management, you need cryptocurrencies, can you just license the pocket doc infrastructure?
If you need cryptocurrency, you don't. Yeah, I mean you can license our platform. Yeah, completely. And then what you actually do is you depending on the level, you actually engage to be a node validator on blockchain.
What about an alternative to blockchain like DAGs?
Yeah, well, I mean, like I said, there's a reason I had a tree structure up there for game theory.
Yeah.
I mean, GitHub's a Merkle tree. I think that the terminology blockchain is going to be different things to different people. Algograph, check it out. It's literally a straight line hashing function that's computing incentives. So, I mean, so I think cryptographic techniques are going to evolve. I think the architecture is going to evolve. It's a great question. Yeah.
Do you have a top investment pick in the identity management crypto space?
Yeah, you're popular.
That's all I probably, yeah.
But right now,
As a co-founder and C-level person, I got to figure out.
there's no way for us to buy into that today.
Not yet. I mean, yeah. I mean, that's a great question. Like, there's not too many companies that are actually, have a crypto asset framework, with the exception of Ethereum. But there's companies that are doing AI on crypto assets.
Well, Civic is one of the identity management cryptos.
So we do have, you can go sign up today.
Yep.
There's an ID management API
Yep.
today that you can use. Our production deployment of .chain identity is going to be next quarter.
Yep. What was the?
APIs won't change much. Right? It'll be just another version. So yes, you will be able to take advantage of that.
Yeah, from an investment I think you were talking in terms of investment standpoint, but here's our, that's the roadmap. But you were talking about actually investing in, right?
Yes.
Yeah, that's a different animal.
You talk about getting in early, right, for protocols and whatnot.
It's all about the FAT protocol, yep. And if it isn't obvious, we're defining the third protocol, probably the first one in help.
Right,
Great
so
question.
We would like to be involved in that early in the investment process as well.
Okay, you know where to, I'm right. We can talk afterwards. Who are you with?
Copus.
Okay, cool. Somebody had one more question? Yep.
So, do you see integration with other like blockchains? Like, for instance, like in financial services, maybe standing up a similar chain where you have an individual as the asset and
Yep.
transactions around, or do you envision Pocket Doc being kind of like the chain that?
Do you remember I said network of networks? So, you know, we're going to add Ripple XRP atomic swaps to Pocketdoc. This is all about transparency, and my most hated terminology in health is interoperability. Great question. You know, if you are not a network function, you could die probably. I mean, it's going to be horrific over the next 10 years. Great question.
Standard Hyperledger, ILP,
Yep.
protocol.
Yep, I mentioned Interledger Protocol, yep. Yeah, check it out.
All right,
Cool.
guys. Thank you again for coming.
Thank you.
Thank you.
Thank you.